In this section, we want to introduce both the addition and multiplication rules for probability. Before we can use the addition rule for probability, though, we first need to understand what we mean by events that are mutually exclusive or not mutually exclusive. So two events are mutually exclusive if they cannot both be true at the same time. In example 1, we'll look at a couple of cases here and determine whether these are in fact mutually exclusive events. In part A, we draw a single card from a standard deck, and the card is either an ace or a king. So those are the events that we're interested in. The first possibility is that we draw an ace, and the particular instances that we would have there would be an ace of hearts, an ace of diamonds, an ace of spades, or an ace of clubs. So what we're doing here is essentially generating the sample space. The other option that we are interested in is if we draw a king. So similarly, we could draw a king of hearts, a king of diamonds, a king of spades, or a king of clubs. Looking at our list of outcomes that we would consider a success, there's no overlap between those, which we could possibly determine even without generating this list. There's no overlap between the aces and the kings. Since there's no overlap, then these two events are considered to be mutually exclusive. In part B, we draw a card from a standard deck, and that card is either a club or a king. So in this case, we could list out all the possibilities for clubs. So that would be all the numbered cards, 2 through 10. Then we would hit the face cards, jack, queen, and king, and then the ace. So all of those are clubs, or possibilities for clubs. And then the other outcome that we would consider success would be drawing a king. So again, this would be the king of hearts, king of diamonds, king of spades, and the king of clubs, the same list we had in part A. In this case, we do have overlap between these two different outcomes. So when we look at our list of kings, we have the king of clubs as one of those options. And in our first group, we had a king that was the king of clubs. So that outcome can occur in both of these groups. There's overlap between these two groups, so these are not mutually exclusive events. We have an outcome that can fit both of those categories. In part C, we want to draw a single card from a standard deck again, and we either get a heart or a spade. So if we pull a card and it's a heart, there are 13 options there. Pull a card and get a spade, there are 13 options there. A heart can't be both a card can't be both a heart and a spade, so these would be mutually exclusive. There's no overlap between those two groups. There's no outcome that fits both of those criteria. Now let's take a look at this in terms of rolling a six-sided die. So if we roll a fair six-sided die and the result is a 4 or a 6, are those outcomes mutually exclusive, or are those two events mutually exclusive? So the first event is getting a 4. Second event is getting a 6. The number can't be both 4 and 6, so these are mutually exclusive. In part B, we roll a six-sided die, and the result is either 1, so that sample space would be 1, or even, meaning 2, 4, 6, just 2, 4, and 6. So there's no way for a number to be in both of those categories, so this would be mutually exclusive again. In part C, we roll our six-sided die again, and the result is odd, meaning 1, 3, or 5, or less than 3, so 1 or 2. Again, we have a single instance, there could be more, but we have a single instance of overlap between those two outcomes, so these are not mutually exclusive events. We'll need to ask this question anytime the addition rule for probability is the approach we want to use, because that will determine something about the approach that we use, or how we approach the problem, which we'll get to in the next video.